In this video, we proved that Pn, nth pentagonal numbers are given by Pn equal to half the product of n, 3, n minus 1 for n equal to 1, 2, 3, 4 and so on. This question is obtained from the textbook Elementary Number Theory by David M. Burton. In order to solve this question, we need to know what are pentagonal numbers. To understand what are pentagonal numbers, let's look at the figure 1, 2, 3, 4. First one is simply a dot. There is only one dot, and we say that pentagonal number P1 is exactly equal to 1. The second figure consists of 1, 2, 3, 4, 5 vertices of a regular pentagon of, let's say, side measuring 1 unit. Let's say the side measures 1 unit, and there are 5 number of vertices: 1, 2, 3, 4, 5. So there are 5 dots, and we say that P2 equal to 5. P2 equal to 5 because there are 5 dots. Now let's look at the third figure. Again we can see there are pentagons, but in this case we can see 2 number of pentagon. The inside pentagon consists of 5 vertices, and we say that there are 5 dots, but there are something more than that. As we said, distance between consecutive dots should be 1 unit, so we mark one more dot. Distance 1 unit, distance 1 unit. So we got 3 dots and another 3. 1, 2, 3. And something more, distance is 1 unit. The second pentagon measures 2 unit in length, and distance, if we keep 1 unit, then we find 3 plus 3, that is 2 times 3 plus 1. So P3, the number of dots in the third pentagon, equal to, we can write simply as P2 plus 2 times 3 plus 1. Can we see similar pattern? Observe that fourth figure consists of third figure and something more. So again P4 equal to P3 plus something more. How many dots? If it is side measuring is 1 to 3 unit, then we can place 1, 2, 3, 4 dots, and then another 1, 2, 3, 4. So P4 is P3 plus 2 times 4 plus something more, 1, 2 plus 2. Can we see general trend? The answer is yes. We can say that Pn equal to Pn minus 1 plus 2 times n plus n minus 2. Of course, n has to be greater than or equal to 2. So P2 equal to P1 plus 2 times 1 minus 1. So it doesn't agree for n equal to 2. P2 equal to P1 plus, yes, it agrees. P2 equal to P1 plus 2 times 2, that's 4. 4 plus 2 is 6. 6 minus 2 is 4. So P2 equal to P1 plus 4. Yes, it's true. Now, we can write this expression as Pn minus Pn minus 1 equal to 3n minus 2. Somehow we want to find the exact expression for Pn, or in other words, we want to solve this recurrence relation. We start by n equal to 2. We get P2 minus P1 equal to 3 times 2 minus 2. Again, if I choose n equal to 3, I'll get P3 minus P2 equal to 3 times 3 minus 2. If I choose n equal to 4, then I'll get P4 minus P3 equal to 3 times 4 minus 2. If I choose n equal to 5, then I'll get P5 minus P4 equal to 3 times 5 minus 2. If I add it, then I can cancel P4, P3, P2. I'll be left out with P1. If we proceed this way, and let's say if I choose n equal to n minus 1, we simply replace n by n minus 1 to say that Pn minus 1 minus Pn minus 2 equal to 3 times n minus 1 minus 2. Let's add those. Observe that we will be left out with P1, and P1 is simply equal to 1. Just for making our work easier, we can write P1 equal to 3 times 1 minus 2. So it will be easier for us to add. Let's call this one to be equation 1. Let's call this one to be equation 2. This one to be 3. This one to be 4, 5, and so on, and so on. Let's call this one to be n minus 1th equation. Oh, I should write one more. Pn minus Pn minus 1 equal to 3 times n minus 2. Let's call this one to be nth equation. So you got n number of equation, and let us add it. Adding the n number of equation. You see that P1 gets cancelled with P1, P2 gets cancelled, P3 gets cancelled, P4 gets cancelled, Pn minus 1, Pn minus 2 all get cancelled. So you'll be left out with Pn only equal to, we are adding 1 plus 2 plus 3 plus 4 plus dot 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 plus n. That's equal to n times n plus 1 by 2. The number 3, that's common, we can write outside. And how many times does 2 occur? It occurs n times. So n times 2 or 2n. Can we simplify it? Of course, yes. We take the LCM 2. (3n) square plus 3n negative 4n, so minus n. That can be written as, we can take n common, so n by 2, 3n minus 1.